All right, today we're doing 5-7, the Pythagorean Theorem. I really like this section. It's just cool. So anyway, I will probably go a little bit more in depth. This will pop up again in Math 8 or in pre-algebra. But if you get it now, it just makes it easier later. And it's just a cool section. So Pythagorean Theorem basically is this. Goes off of Pythagoras. And if you ever study like math history, the Pythagoreans, they're some weird dudes. But I digress. So Pythagoras came up with this, though, him and his group of homies. And how it's good is if you have any right triangle. So it only works if you have a triangle that's a right triangle. There's a different way to do it for non-right triangles. But if you have a triangle that has a 90-degree angle, like this thing right there, you can find any side if you know the other two sides. And really, we're going to break this into two different types of equations, or two different types of problems, but we'll get to that soon. So, okay, so you can find missing sides of any right triangle. And a right triangle is a triangle with one 90-degree angle like that there. Using, in red for dramatic emphasis, a squared plus b squared, all lowercase. A squared plus b squared equals c squared. And the reason those are lowercase is that they all stand for the length of a side of the triangle. And all right, so if we go through and label up our triangle, C is the one that really matters. C has to be this one right there. So if you have a right triangle, one side is going to be the longest. It's always going to be directly across from that 90-degree angle. It doesn't touch the 90-degree angle. And it's called the hypotenuse. Hypotenuse. So Hypotenuse. Hypotenuse. That has to be C. That has to be here going by itself. Make sure you get that in the right spot. The other two sides of the right triangle are both going to be called legs. And it doesn't matter which one you call A and which one you call B. And if you look at the equation, whether you have these numbers switched or not, you're going to get the same value for that side of the equation. But those are going to be there. And I'm going to write in the names. That's a leg and a leg. But the legs are going to be, the two shorter sides are going to be the sides that are attached to that 90-degree angle. All right, so I got into my space a little bit here with this line if. Oh, there it is. So I'm going to write this here. If a squared plus b squared does not equal c squared. So we just said that this Pythagorean theorem, a squared plus b squared equals c squared, which will definitely be on the test, know it from memory, works for any right triangle. Then if you would put in those sides, if you put in the two legs for a and b, you put in c, the length of that hypotenuse, the longest side, and you find that it's not equal, then you know you don't have a right triangle. So if a squared plus b squared does not equal c squared for a triangle, it's not a right triangle. So it's not a right triangle. All right, I'm going to jump down. We really have two different types of problems. And I made them both into story problems because you'll see some of these here. So working with my father-in-law this past summer, we were building a shed in his backyard. The question came up, how long do you cut this board right here for the roof? Because that one's kind of hard to measure. I mean, you can measure across here, you can measure the height. So what I'm really doing is I'm talking about this triangle right here, and I'm trying to find this side. So I'll put an X right there. So if we were to do that, we could find one side of a right triangle. This, if we built it right, should be a 90-degree angle. But we need to know the other two sides. So if we had an 8-foot piece of plywood going front and back, and we wanted this side here, then the top part, the total to be 8, the shorter side of my triangle then is going to be 4, because I want it to meet right in the middle. So then I could put a 4 right there. So this is just kind of like a blown up version of that triangle, so it's easier to work with. So I have a 4 there. I have a 3 here. This is my 90-degree angle. Now I'm trying to find X. What I would recommend doing, make it easy. Go through and first just say, all right, C. C has to be this side there. That has to be C. These two, it doesn't matter which one I call A and B. I'll maybe call 3 the A and 4 the B, but you're welcome to write it the other way around if you want to. Show your work. It makes it so much easier, and it doesn't take longer. A squared plus B squared equals C squared. So I'm going to write that out. And if we've labeled up our triangle and we've written the Pythagorean theorem, really it's just plugging and chugging. It starts to get easier. So all right, so I have a is going to be 3. So I put a 3 right in there for A, and I get my 3 squared. Plus B, we copy down the 4, so that's 4 squared. And C then is my unknown, so I have x squared. All right, now if I go through and do this, I know everything there on the left side of that triangle, so I could punch that into my calculator, I could do it all in my head, but I can get one number here on the left side. So 3 squared, if you want to do it in your head, 3 squared is 9, plus 4 squared is 4 times 4, so that's 16. 9 plus 16 then gives me 25. So I get a 25 equals, I made that a little bit ugly, sorry about that, so 25 equals x squared. The common mistake is people just leave it here, woohoo, found it, it's 25. But if you look, 25 isn't x, it's x squared. So going back to what we just did in the last lesson, we need to undo squaring. So the inverse, or a lot of people think of it more as the opposite, but the inverse technically, to undo squaring x, to just get x by itself, we do square root. If we square root 25, we get a 5. So 5 then is going to be x, it's going to be the length of that missing side. So I started out, kind of hit it briefly, then when I got to this question I said, okay, there's really 2 types of problems. A type of problem where you're solving for the hypotenuse, they're all going to be in this kind of format. You're going to have all the numbers you need here on the left hand side, and then you're solving for something over here. So they'll follow these steps. If instead our unknown is going to be one of these legs, then it's going to be one more step that you have to do. So let me quick kind of jump down to here. It's a break time. Hopefully no kids come in and interrupt us. If you get a story problem, makes it way easier if you just draw it. And if it's in this section, you know you're going to get some sort of a right triangle. But I'm going to say I'm working on my house. I have the side of my house. And I have a 20-foot ladder. I'm going to lean that up against my house. If you draw it to scale, that's ideal. But you know, it doesn't have to be. Just if it's to scale, then it's easier to tell if your answer kind of fits or not. But so I'm going to say that's side of my house. There's my ladder kind of leaning up against it. That's a right angle right there. And the base is 5 feet from the side of the house. So in other words, that's going to be 5 right there. So I have my right triangle. If you wanted to, you could go through and kind of erase some of that to make it look a little bit more triangular. And now you'll notice, if we go through and label things up, I always start with C, because that's the one you got to make sure is the hypotenuse. So C has to be 20. So we're going to know what's on the right side of that equation. A and B don't matter. I'll maybe call this A, and I'll call this B. So B is kind of like my unknown. You could make it an X. You could leave it as B. It's totally up to you. People are often more used to solving for X, so I'll probably put that in my equation. But then again, show your work. Please, my friends, show your work. And hey, can I get you in a minute? You're welcome to come in. That's fine. I'm just making a math video. All right, so A, if I plug A in, that's going to be my 5, so I get 5 squared. And B, that's my X value. C then is 20. So I end up with this here for an equation. And it's kind of ugly. Okay, we can go through and let's simplify that as best we can. So I have a 5 squared. It's not going to be 10. It's not 5 times 2. It's 5 times 5. So we have a 25 right there. Plus x squared equals 20 times 20, or 400. All right, now we need to work through and get x by itself. So we go through and do order of operations backwards because we're solving for a variable. We first look, what can we move by addition, subtraction? That 25 is connected by addition, and it's a positive 25. Technically, it's that positive 25 that means we have to subtract it. So I subtract 25 from both sides, and that leaves me with a positive x squared because these two just kind of drop out. So just x squared, or positive x squared, equals 375. Now I'm almost done. We can't quit there. We need to say x squared is 375. So we need to get rid of the squared by doing square root. And the square rooting of x squared just gives me an x. So if we punch square root of 375 in a calculator, it's going to come up with about 19.4. That's it. Let me know if you have questions.